Hello, I'm happy to have you here again. This is the last study session in biochemistry, which will discuss vitamins, coenzymes, and their functions. Please sit back to enjoy this lecture. The roles played by vitamins of dietary sources or synthesized in man cannot be overemphasized. This is further emphasized by the discoveries of deficiency, symptoms, syndromes, and toxicity conditions. This study is to open us to the importance of vitamins in medical biochemistry and to provide an adequate knowledge view of the biochemistry of vitamins. At the end of this study, you should be able to understand the chemistry of vitamins, you should be able to discuss both water-soluble vitamins and fat-soluble vitamins. What are vitamins? Vitamins are organic nutrients that are required in small quantities for a variety of biochemical functions and which generally cannot be synthesized by the body and therefore must be supplied by the diet. The absence or relative deficiency of vitamins in the diet leads to characteristic deficiency states and diseases. Vitamin deficiencies can be avoided by consumption of food or feed of a wide variety in adequate amounts. Many vitamins are destroyed by oxidation, which is a process that's sped up by the action of heat, light, and certain metals such as iron. Vitamins can be classified based on their solubility into water-soluble vitamins and fat-soluble vitamins. Owing to these characteristics too, storage of water-soluble vitamins is limited, thus must be provided regularly. The body, on the other hand, is able to store surplus soluble vitamins so that the toxicity conditions known as hypervitaminosis can result from excessive intake of fat-soluble vitamins. Let's look at the water-soluble vitamins. Water-soluble vitamins consist of vitamin B and C. And vitamin B exists as a complex, and these vitamins are essential for animal nutrition. Vitamins of the B complex function as cofactors, accessory non-protein compounds necessary for the activity of an enzyme in enzymatic reactions. Vitamin B deficiency. Vitamin of the B complex is rare. Nevertheless, definite syndromes are characteristics of deficiencies of specific vitamins. Thiamine, for example, is widely distributed in foods, brewer's yeast, unrefined cereals, grains, beans, peas, green leafy crops, egg yolk, kidney, and pork muscle. Symptoms of thiamine deficiency include loss of appetite, emaciation, muscular weakness, and a progressive dysfunction of the nervous system. Riboflavin is another example of another vitamin B compound, which is found in yeast, liver, kidney, milk, and leafy crops. Symptoms of riboflavin deficiency include poor appetite with consequent retardation in growth, vomiting, skin eruptions, and eye abnormalities. Rich sources of niacin, which is another complex of vitamin B, are liver, yeast, granules, and sunflower meals. Deficiency symptoms include poor growth, enteritis, dermatitis, bone disorders, and inflammation of the mouth and upper parts of the esophagus. Vitamin B6 is widely distributed in yeast, liver, mackerel, milk, avocados, eggs, meat, pulses, and cereal grains. We have cobalamin, which is synthesized exclusively by microorganisms and it is only found in foods of animal origin, like liver. Deficiency symptoms include severe growth retardation and high mortality in young growing human. We have vitamin C, which is another example of water-soluble vitamin. The vitamin C, which is chemically known as high ascorbic acid, is reminiscent of glucose, from which it is derived in the majority of animals. Ascorbic acid is colorless, crystalline, and its destruction is accelerated by exposure to light. Ascorbic acid and its oxidant product dihydroascorbic acid play a role in collagen synthesis, bioformation, and ion absorption. It may also act as a general water-soluble antioxidant. Sources of vitamin C are citrus fruits and green leafy vegetables. Synthetic ascorbic acid is also available, and the deficiency symptoms of vitamin C is scurvy. This is characterized by edema, emaciation, and diarrhea. Failure in collagen formation results in structural defects in bone, teeth, cartilage, connective tissues, and muscles. Moving to the fat-soluble vitamins. These vitamins require normal fat absorption in order to be absorbed efficiently. And on your screen, you can see the fat-soluble vitamins that is tabularized on the screen. The fat-soluble vitamins are the vitamin A, D, E, and K. In vegetables, vitamin A exists as a provitamin in the form of the yellow pigment, beta carotene, which consists of two molecules of retinal joined at the aldehyde end of the carbon chain. The provitamins of vitamin A, and which is beta carotene, are usually accompanied by chlorophyll in plants. Thus, green foods are excellent sources of beta carotene. Other plant materials such as carrots, tomatoes, and yellow maize are also rich in carotene. The D vitamins are limited in distribution. They rarely occur in plants except in sun-dried roughages and the dead leaves of growing plants. In animals, vitamin D3 occurs in small amounts in certain tissues and abundantly or only in some fishes. Halibut and cod liver oils are rich in vitamin D. Vitamin E, which is tocopherol, is widely distributed in foods, grain, cereal grind. Animal products are relatively poor sources of this vitamin, and vitamin K is present in most green leafy vegetables. Animal sources include egg yolk, liver, and fish meal. Vitamin K is also known as the coagulation factor or the K factor due to its role in prevention of hemorrhagic symptoms produced in chicks. Thanks for listening. Bye for now.